All right, so let's go ahead and get started. So I'd like to thank everyone who's joining us today. Welcome to CNCJ's September Meetup event. My name is Harry Lee. I'm the organizer of CNCJ. Today we have Julian joining us, who will be showcasing Google Anthos. Okay, he's going to be talking about how he's going to use Google Anthos to unlock cloud-native hybridization awesomeness. Okay, so just a few housekeeping items aside. This session is scheduled for an hour. However, we will be leaving the Zoom meeting open if people would like to continue the discussion afterwards. This talk has a technicality rating of 3 out of 4. So it is quite technical, and you will be hearing quite a bit of Kubernetes and technical jargon, so strap in. Questions are always welcome, but keep them on topic. And to not disrupt the session, Julian will answer your questions at the end of his presentation. So Julian is okay with keeping it interactive, but as not to disrupt his flow, let's start the Q&A interactiveness during the demo session. So we want to make the session as interactive as possible, and hence you do have the ability to unmute yourself. And if you don't want to ask the question, you can also just type it out in the chat window. The session is being recorded and moderated, so please be respectful towards the speaker and your fellow participants. You will be kicked out if you do not abide to our code of conduct. This session will be available on YouTube under the official CNCF YouTube channel in the next 2 days. So with that, I'll hand it over to Julian to kick off today's presentation. The floor is yours, Julian.
Cool, thank you, Harry. Good evening, everyone. Thanks for joining the day before public holiday. Cool, I'm going to be kicking off a bit of a showcase on Google Anthos and what it is and what it entails. And just to get the ball rolling, just to start with a few thank yous. So just a few thank yous to our partners that have enabled access to Anthos and access to infrastructure to deploy it, including DigiCloud Africa, IOCO Cloud Services, where we're hosting our GKE on-prem deployment, Google, specifically Google South Africa, for availing themselves as well, towards getting everything deployed and up and running. And then, of course, Harry and the Cloud Native Computing Johannesburg chapter. There's a subtitle to this talk called The Amazing Widget Story, and we will get into that shortly. Just a quick note and a few plugs. Who does? That's me. I'm Julian Gurka, also known as Jules, and I work for a company called LSD. We do open source tech, specializing in cloud native open source tech. And feel free to reach out at any given point in time. We're always available to talk about cool cloud native technologies in the open source space. Okay, great. So a little bit of a preamble, and to perhaps kind of frame the technical demo to follow, a little bit of a narrative and a story that perhaps some of you guys can relate to. So I'm going to regale you guys with a tale about Amazing Widgets. Amazing Widgets are a SaaS startup that began in a garage, much like this one, although looking at this picture now, it actually looks like a little bit more of a apartment. But anyway, that's where they started. And they began by building and exposing a backend API that does widget pricing comparison. What widget pricing is, I'm not too sure, but that's what they did. And of course, like any clever SaaS startup, there was a massive uptake in their backend API service, which they monetized, of course, and within very short order, lots and lots of bargain hunting widget seekers looking for the best prices started to make use of their APIs. And they were getting a lot of requests to their backend service, and transactions blew up. And of course, all the dashboards lit up and things went crazy. Being a scrappy startup, a lot of their infrastructure and even their application architecture was cobbled together, out of necessity. And with the massive surge in demand for the best widget pricing in town, their backend service started to take a lot of pressure, and they noticed that from a scalability as well as a mobility perspective, they had quite a lot of limitations, both infrastructurally and architecturally, in terms of their application. And we can actually have a quick look at what their monolith backend API looks like. Just click on this guy. And here we can see this is their this is the backend monolith service, and there are quite a few API endpoints that have been tied down into this one singular service. And just for comparative purposes later, I don't want to give away too much, but I'll just quickly run a little test query. And I want to draw everyone's attention to the name of the first product here as an automatic fuzz ingester. And I guess that's a widget. And from a mobility perspective, we can have a look at their architecture from an infrastructure perspective. And what we should see is fairly traditional virtual infrastructure. They've got two VMs running across two regions with an instance group and a load balancer running somewhere, fairly stereotypical. So when I run this query and get back some products like automatic fuzz ingesters, what I'm actually hitting is this monolithic backend, one of these two guys behind the load balancer. Okay, so that's pretty powerful, of course. And of course, sorry, I've got the Zoom thing in the way. Of course, that wasn't really working for them as they began to scale and see higher demands transactionally. But lucky for them, there was an amazing technology called Anthos that allowed them to really catalyze their journey towards becoming a more cloud native centric SaaS company and leveraging cloud native paradigms and architectural patterns to scale and allow for better mobility and transactionality. So I guess what everyone's wondering is, what is Anthos? And the Google definition is it's a modern application management platform that provides a consistent development and operations experience for cloud and on-premise environments with features such as what's about to follow. Where I kind of see Anthos, what I see it becoming is essentially an extension of, the GCP platform and suites of services extended into data center. So if you're an enterprise, it really gives you a lot of that flexibility in terms of hybridization, having services run on-prem with parity in, your Google Cloud, for example. And I think, I don't want to preempt too much, and I can't speak for anyone other than my own thoughts here, but I think we'll start to see more and more services become available in Anthos on-prem. So kind of extending GCP capability into your data center. We're going to be running through some of these capabilities as part of the technical demo. And the first thing, well, actually technically the second thing that we're going to show, or I'll show, will be GKE on-prem. So this is, the Google Kubernetes engine running in data center on traditional, infrastructure. So all of the power and flexibility that you get from Google Kubernetes engine. And, I will say, having worked across all of the other managed cloud Kubernetes services, that GKE is really well polished and quite mature. And GKE on-prem is essentially being able to deploy GKE in your data center, have it federated with GCP, and manage everything from your GCP control plane. So that's GKE on-prem, and that's one of the Anthos capabilities that gets delivered. Migrate for Anthos, I see this as being incredibly powerful and having a significant amount of potential for companies big and small looking to rapidly benefit from paradigms like containerization. And potentially you could argue I guess, semantics around whether traditional workloads should be containerized. But I think there are definitely immediate benefits in terms of scale and portability that you get from containerizing even fairly traditional or legacy workloads that support it or permit it in a way. So Migrate for Anthos enables this in a very, very quick and rapid way, and is available for both Linux and Windows across VMware, AWS, Azure, and of course, Google Compute Engine. And I'll be running a quick video of Migrate for Anthos as part of our amazing widgets cloud native journey. Just due to time constraints, it takes about 12 minutes to do it in real time. So I've edited it down to about a minute, and I'll just talk over it or wrap something while it happens. Up next, we've got Anthos Service Mesh, and I'll be showing a little bit of Anthos Service Mesh as part of the amazing widget story. But Anthos Service Mesh is based on Istio. You can deploy it in GKE on-prem or in GKE. And one of the additional things that I'm kind of neglected to mention is that you can run Anthos across any public cloud. So, or at least you can run it in AWS, GKE, and of course on-prem. I don't think Azure yet, but I probably is coming. So, it gives you a lot of kind of multi-cloud capability as well. And Anthos Service Mesh can be deployed across those Anthos environments as well, including GKE on-prem, based on Istio, of course, and Envoy, and that are that is kind of the backing service mesh technology with a whole bunch of additional capabilities, telemetry, tying into things like Stackdriver inside of GCP, and Anthos kind of give you a very nice, singular pane of glass where you can do very cool things like SLI and SLO tracking, and we might show some of that as part of the amazing widgets story as well. Just to kind of keep things moving, Anthos config management. This allows you to do a lot of almost GitOps type automation across Kubernetes platforms, across disparate Kubernetes platforms. It's a CRD that you deploy and essentially will make sure that there's an enforced state for anything inside of a Git repo. So very much a GitOps slant to being able to enforce and drive policies from typical traditional Kubernetes RBAC policies through to CRDs and other resources. Last thing we're going to talk about, and I believe it's quite a growing ecosystem, so I actually might have missed a few Anthos features, but binary authorization allows you to concoct from simple to pretty complex authorization policies as to what containers are allowed to run inside of your Anthos Kubernetes environments. And this could be everything from a simple, source-based policy to say, I don't want to allow any containers to be deployed from Docker Hub, down to fairly complex, build and deploy time policies that kind of tie into a cloud build within GCP, which is a CI/CD tool. Okay, so getting back into the central theme around amazing widgets, where they were at with their fairly, let's say, legacy architecture, and what they needed to do to really jumpstart or even leapfrog into a far more cloud native enabled architecture. So the first thing they were able to do is leverage Migrate for Anthos to containerize their backend API virtual machines, even though that service was monolithic in nature and comprised of all of the different API endpoints in a single service. They were able to use Migrate for Anthos to rapidly containerize, and then I think very very powerful capability within Anthos, deploy that containerized or that migrated workload that has been containerized off of a virtual machine into their Anthos GKE on-prem cluster. So that's quite a powerful thing if you think about it in just conceptually, taking a virtual machine and a workload inside of a virtual machine, and essentially through either a click-driven process or using a client tool, having a container automatically built for you that you can then deploy into Kubernetes is quite a massive enablement factor, especially if you're a large enterprise that has a lot of traditional virtual infrastructure that you might want to containerize. Of course, once the monolithic service was containerized, running in their data center within Kubernetes, GKE on-Prem, they could benefit from some of the fairly traditional capabilities within Kubernetes that I think a lot of people who've been working with Kubernetes take for granted, like auto-scaling. You can obviously do that in an instance group across pretty much or an auto-scaling group across different cloud providers. Quite a different thing to do it on-prem in traditional virtual infrastructure. And essentially, that's exactly what they were able to do in data center on traditional VI, auto-scaling their services. Then they took a minute to think about their application architecture and decided the monolith wasn't really working for them from a scale perspective. And 4 months to 7 years later, they came out of that garage with a fully microservices-enabled architecture, which was then able to leverage the capabilities of Anthos Service Mesh to provide really great observability between dependent services and amazing things like service level objective tracking and being able to define service level indicators across different microservices. So just to kick off their journey, this is how they started. And as I said, I've kind of edited this video down to about a minute or so. It normally takes about 12 minutes to run. And just to underpin that, Migrate for Anthos can be executed against VMware virtual machines, AWS instances, Azure virtual machines, and of course Google Compute virtual machines as well. And just to kick things off, and I'll kind of narrate through it. So here you can see me jumping into Anthos, and I'm going to use migrate to 2 containers. Used to be called Migrate for Anthos. That's how I still kind of know it. One thing that you don't see in this video, I'll quickly pause, is the Migrate for Anthos requirements are a processing cluster, which can be GKE on-Prem or GKE. And once you've created and enabled a processing cluster, you're essentially installing a whole bunch of Migrate for Anthos CRDs, essentially an operator that then allows you to pull down the actual virtual machine image, and it does its magic and creates a Docker runnable container for you. So, whoops, go back there. So we went too far in. So you don't see the provisioning of the processing cluster. As I said, it could be in GKE, could be GKE on-Prem. I've created a source already, which I'm going to point to an existing GCP virtual machine, one of those 2 backend virtual machines running our monolithic API that you saw. I gave it the VM ID, and the migration intent I set to build me an image. So what this is going to do is generate a migration plan. I'll just quickly pause here just to show. So this is essentially where, if you want to, you can go and modify how your virtual machine will be converted into a Docker container or a CNA compliant container, but I think it's really just a Docker container. So if there are any services or anything that you want to go and modify or turn off or cut out, you can go and do that. So you can, with some customization, get a fairly thin Docker image out. Of course, it's not going to be as thin as if it were a containerized microservice from the beginning. And in this instance, we are running a monolithic Python application, and I have elected to not make any changes to the migration plan. So we're going to get the full virtual machine image in the Docker container. Yeah, I might need to stop pausing. Apologies. Cool. So once that migration plan is created and we're happy, we can save and we'll generate the migration artifacts, and that will essentially kick off the migration of that virtual machine into a container. And this includes things like persistent volumes if you do have a stateful container. What we missed is probably about 10 minutes of that virtual machine being all of the VMD or the data being pulled through and then containerized. And here we can see that there is now a container image that's been pushed through into our container registry, which is GCR. And along with that are certain migration artifacts, such as a deployment YAML, a Docker file, and there are two image types that get created, a runnable base and a payload image. You only really need to run this payload image. You don't really need to worry too much about the runnable base if all you want to do is deploy your image, get it up and running. I do want to draw attention to the virtual size. So obviously there is a little bit more additional OS overhead going into these containers, but that's still not super significant. And if I had customized that migration plan, I'm quite confident I could get it down to something even smaller. And that's obviously with the Python runtime and some of the OS services on top of it. Okay, so we have, as amazing widgets, taken our traditional virtual machine and our monolithic service and built a Docker container without having to do anything other than use migrate for Anthos and point it to our VM. What we did next as amazing widgets, or what they did, I don't know if I'm part of them or not anymore, but the next step was to deploy GKE on-prem into a data center. So just to talk around how Anthos and GKE on-prem is actually deployed or stood up, you essentially need two or three things. You need a project in GCP. You need a Anthos APIs enabled, and then you need the target infrastructure. Currently vSphere based. I think bare metal is coming, if not already GA, but I know that bare metal is on the horizon, I believe. You can also deploy GKE into AWS using Anthos. This was deployed within Ioko Cloud Services virtual vSphere estate, and it took about 4 or 5 YAMLs. The process is essentially you pull down an OVA, you need a vSphere service account, which obviously I've omitted in this YAML. You provision an OVA, which is an admin workstation, which also plugs into vSphere to actually do all the standing up and provisioning. Once that's up and running from your admin workstation, you provision an admin cluster and any user clusters or working clusters you want. So an admin cluster, if you think about it, if you are familiar with GKE or even EKS or AKS, that's essentially where the control plane runs, and your user clusters will have their distinct Kubernetes control planes running inside of your admin cluster. And then you'll have working nodes that form part of each user cluster. So it provides a nice kind of multi-tenant pattern in a very similar kind of way to GKE and other cloud providers, where everything ties into a single admin cluster, which is kind of the control plane above all control planes, and then you just tie in additional nodes afterwards. Just to show you what this looks like from an actual vSphere perspective, and I think kind of showing virtual machines, if anyone's ever touched VMware or vSphere, this is what our Anthos GKE on-prem lab looks like. There are a few different virtual machines that are part of the admin cluster, and then we have got essentially the integrated seesaw load balancers that we've opted to use in this lab environment. Seesaw is really cool. It's out of Google. It's a high-performance load balancer that actually integrates into Kubernetes. And it allows you to do things like create load balancer type services within Kubernetes without having to have a Google load balancer or Elastic load balancer or Azure load balancer in front of you. So if you're running on-prem, historically that was always a bit of a tricky thing. Ingress really made a lot of that complexity go away. But if you need to do any kind of layer 4 stuff, it's going to be a node port, which means that you typically would have to have some kind of load balancer config up in front of that. And of course, having a service of type load balancer was not really available to you unless you're running on OpenStack. Well, Seesaw allows us to do that. We can create load balancer services inside of more traditional private cloud-based infrastructure, and allow users to have that kind of flexibility. So it's a really nice capability there. So that's the GKE on-prem footprint right there that you guys are seeing, and I'll show you what the cluster looks like when we go into the actual technical demo, which we're about to. How much time? I'm actually doing quite well. So we've taken our virtual machine, containerized it. It's got our monolith service inside it. We then deploy it into our GKE on-prem cluster. And within GCR, if you ever have used it as an image registry, you can actually right-click on any image and select deploy and deploy it into a cluster. You can do that with a container that's been built by Migrate for Anthos, and you can do that straight into GKE on-prem. So pushing it from the cloud-based container registry all the way into data center. But there is a little bit of magic you have to do to get it working with the you can't use the default deployment YAML manifest. You have to make a few modifications, and I'll quickly show that just to illustrate what that does look like. So I'll jump in and show exactly as I had our virtual machine-based service that was running the backend API, the lifeblood of amazing widgets, now running fully containerized within Kubernetes on-prem with parity, and allowing for auto scaling and easy deployments, and of course all of the mobility and parity that you get, or at least parity assurance that you get with containerization. Then of course the team went and tore apart the monolith, and we were able to use the Anthos service mesh to define some service level objectives and actually track and trace through our microservice application. At that point, as Amazing Widgets, we were leveraging a staging cluster within GKE and our production cluster within GKE on-prem. So you'll see kind of those two being split. And time permitting, I'll show some potentially how that CI/CD workflow allows us to build and deploy it inside of GKE as a staging, and then potentially launch down into GKE on-prem. But there's quite a lot to show. So just quickly to take you guys through to that API endpoint we're now running in our on-prem GKE environment, so GKE on-prem, that's what it's called. And if I query our API, so this is now coming from a container that was built purely by Migrate for Anthos, coming straight out of a virtual machine, and our first product is that automatic fuzz ingester. So we've got 100% parity of, sorry, these are from some of the load testing things that we'll see shortly. So you've got 100% parity on what was in our virtual machine now running in data center in Kubernetes. Okay, and I'm going to start with showing how that all plugs in. So just to illustrate, we've got our two Kubernetes engine clusters here. One is our Anthos cluster running within GKE on-prem on vSphere virtual infrastructure. And we have our staging environment where we do all our developments and QA, which is running in GKE. Just to illustrate, if we jump in here, you'll see that the type is Anthos, and it's got a whole bunch of resources available to it. And these are the nodes that we actually have in our user cluster. So we're not seeing the admin cluster here, but if anyone wants to see it at the end, I can show what the admin cluster looks like too. So to jump into workloads, and we're going to go to, first and foremost, our GKE on-prem widgets monolith. So this is just running our container that was built from Migrate for Anthos. That endpoint that I just hit is going through an ingress running in our data center, through those load balancers that I was talking to. And just to draw everyone's attention to, there's an HPA that's already been defined here. I'm going to try very hard to not jump out of the GCP console. So what we're seeing is an on-prem Kubernetes cluster managed through, the Kubernetes engine, control window within GCP. Now, what I want to do is illustrate how we can auto scale a service that was a monolith running in virtual infrastructure not a few minutes ago. And how I'm going to do that is by turning on our widgets buster. So widgets buster is a little tool that we wrote to send a whole bunch of requests through to our monolithic service running in GK on-prem. I'm just going to scale it up to 1. And that should send a whole bunch of requests through to our GKE on-prem monolith. So there you can see widgets buster is running. And if we jump back over to our widget serve namespace, within fairly short order, we should see our HPA kick in, currently at 13% out of 30. That's what we set. And we should see additional pods get created. And what I want to just highlight or underpin here is the flexibility that's being enabled. This is a traditional, virtual environment running in a data center where we've taken a virtual machine, admittedly one that was running in GCP, but it could have been a vSphere virtual machine, and used Migrate for Anthos to convert it into a container. And with a horizontal pod autoscaler, we're now auto-scaling what would have been, at least on-prem, a very inflexible, not auto-scale enabled workload. So I think that's incredibly powerful. Just in terms of, there you go, you can see we've now scaled up to three additional pods there from our widget buster hitting the service a bit hard. So just to illustrate the flexibility that's been enabled there in a very traditional on-prem environment. So what ensues then is the clickety-clacking of 1,000 developers decomposing our monolithic service into essentially 3 microservices. And I think real quick, just looking at time, I'm going to rush through this. Those services are actually all stored in cloud source. So we've split apart our monolith. And we should see, when things load, that we have one single code base for our backend monolith, and we have 3 independent code services now. So we've kind of split them out into 3 separate microservices, and these are built and deployed by Google Cloud Build. So these will essentially, let's just go have a look at what the build log says. Sorry, Zoom thing gets in the way. So we've got 2 triggers. If we're building off develop, we go into staging. If we're building off master, we go into pre-prod. And if we build off a release tag, we go into production through a little bit of a GitOps hookup that had to happen. But we're going to now look at using Anthos service mesh in our staging environments to capture a regression or a defect before it even reaches production. At least that's the hope. This can get a little bit unwieldy at times. So first, we're going to quickly flip over to our Anthos dashboard. And you can see we've got 2 clusters registered to Anthos at the moment. One is our GK on-prem, and one is our staging environment. And you can see there's a few different features and capabilities that you can activate. We've actually got config management turned on within our GKE on-prem environment, so config management syncing through to our in-data center cluster. But importantly, I'm going to jump over to our service mesh view. So this is the Anthos service mesh, and essentially this is capturing telemetry from Istio deployed in this cluster. from the Anthos Istio that gets provided. So this isn't community Istio, but I believe you can do community Istio and get it kind of linked up in the same way. I haven't tried that, but I believe it is possible. So this is the Anthos service mesh view. And as we can see here, there's not a lot of stuff happening. So I think let's change that. And let's get some crazy requests going. I'm going to, just like I did for our on-prem monolith, I'm going to jump into our staging tools namespace. So stage is built off develop. And I'm going to turn on our widget buster. As you can see right now, there are no widget buster pods running. The second I scale out, we're going to start seeing a whole load of requests going through. And to illustrate that, what we can do is jump over to our logs. So these are coming through from Stackdriver. And for GKE on-prem, there is a Stackdriver CRD that gets deployed that will feed logs up from your on-prem environment into Stackdriver within GCP. So if we go and pull out the service I'm going to pick on is the least efficient service. It's the one that the first two talk to. And we're just going to look at logs coming in from our pricing service pod. And we can start to see there should be a bunch of requests coming through, price created. So we can see that prices are being generated through our amazing widgets buster. Where we want to look at is our Anthos service mesh. So we've got our pre-prod and staging, and we're going to stick with staging where developers. And just to run everyone through it, there's a topology view, which I kind of like. We need to have some traffic flowing first, though, and that should start to come through any minute now. It does take a little bit of a while to start to actually pick up the requests coming through. And again, this is coming through from invoice sidecars that are automatically injected into our pods using that namespace label that we apply. So kind of if you've got an exposure to Istio, a fairly stock standard way of doing that, and pretty much out the gate, don't have to configure too much unless we want to get into the technical weeds. So here we can see we've got a little bit of telemetry around utilization. The service will be pretty much idle except for readiness and liveness probes. It'll be hitting it, or at least liveness probes since it's already deployed. It's going to wait a little while for the transactions to start to flow from our widget buster, which should cause things to start lining up. While we're waiting, let's run through some of the views that you get from Anthos Service Mesh. So we've got a SLO predefined within the service. So this essentially sets the kind of operating parameters for what is healthy and what isn't healthy within the context of the service. Now, for pricing service, I'm hoping to actually generate some alerts. Some alerts to tell me that this service is actually not within its error budget. And what I'm going to do while we're waiting for the stack to kind of catch up to the metrics that have been generated is I'm going to quickly run through for anyone that's interested how the service indicator has been composed. For this one, I've opted for a window-based measurement. The others are all request-based. And this is because it allows me to actually drop the duration that the monitoring is going to happen. Now, the reason I picked on the pricing service is I know it's the least performance, and I'm just going to drop the latency threshold. So this is responses that we expect this service to kind of be within from a percentile perspective. If I reduce this to 500, I'm pretty certain that we should actually see some responses over that and sustained high enough that we should get some alerts. Also, what I'm going to do is increase our performance goal. And this is all just in, towards the purposes of getting some alerts pushed through. Just give it 98%. Great. Well, we're already out of our error budget. We're starting to see the requests come through, and I think it'll be an easier view if I just drop our timeline down to a more recent window. So we were looking at a window of 1 hour, and you can see already we're well over that SLI with response latencies, and we can go and dig in and see what we're actually responding at. I do have some alerts that are already tethered to this SLO, and you can quite simply just go and compose an alerting policy that will tell you, and you can go and set up how long you want to have, the alert retrospectively fire for, and then, set up different notification channels. I've got email, which probably isn't the best, but you can tie it into things like Slack or any generic webhook or PagerDuty, and you can tie in documentation as well, and that will get sent out to you. So we can start to see, I'm just going to flip back to all of these staging services quickly. As we've got our kind of load generators running now, we start to see that there are some latency measurements coming through, and this is coming through off Envoy and being fed up into Stackdriver and processed in through Anthos service mesh telemetry. We're getting that view. So the product and supplier services aren't being hit that hard. Pricing service is actually the service that marries them all together and queries both products and suppliers. So it's really the only upstream to those two. And I should start to see emails coming through fairly quickly. Just to drill into the different views you get. So if we look at the health, we can actually go and see we're out of error budget, and we can actually get a window into where from a GKE monitoring perspective, what these alerts look like. And if we quickly drill into the metrics that are being tracked, we can actually go and see, what is currently happening. So 641 is when I kind of turned on the widget buster pointing at our staging environment, and we're sustaining about 8 requests per second, which isn't great. It's because it's my code. It should be better. It's Python fast API, which is fully async, but I guess I'm terrible. We're not getting any errors, but we're definitely responding above our 50th percentile in terms of that latency. So, one of the things we could actually do quite simply to rectify this is just turn on auto scaling and have more pricing services or pricing backends responding to requests. But we're leaving it at a single without any HPAs to actually get us over that error budget so that we can actually see where things are going wrong. We're getting quite a lot of detail into what the average request response size is. Fairly small queries, fairly large responses. So really great bad pattern and the kind of service that you want to keep eyes on. And of course, as our load generator is starting to send a whole bunch of traffic through, we will see things like CPU and memory spike. And I think the powerful thing here is, CPU is, so CPU bound service. I think the powerful thing here is, this is all in a single pane of glass. Now, if I wanted to see, the downstreams for this service, this would be the health checks, which aren't happening over MTLS. And this will be the downstream supplier and product service, which the pricing service will query to get product and supplier detail out. And they're well within, fairly healthy, at least 50th percentile for the most part. But we're seeing, it's getting slow responses from suppliers, and we can actually see the amount of requests per second going to each downstream. So really, really powerful, I think. Just, if you're familiar with Kiali, you get, you can get kind of similar levels of accuracy, but I love how intuitive the view is in terms of just being able to dive straight in. I'm waiting for those alerts to come through. Sometimes it takes a little while to catch up. What I'll go and do is just define another alert real quick. I want to save the last 10 minutes for some questions if there are any. And we also get a stream of the logs coming directly off of this pod. So that's tying in the Stackdriver side of things. And here you can see, while these aren't actually errors, these are just, pricing things that are happening. I don't know why, I think it's my JSON logging inside of Python. Let's go in and set up a quick alert. that will look back in fairly short order, send it to my email, and I'm not going to send any documentation because I'm a bad SRE. And let's wait and see for some alerts to come through. So I'm going to stop there. I think that was quite a lot in a fairly short period of time. And I think, yeah, like if there are questions or any discussion points, I'd like to keep it fairly open-ended.
Yeah, cool. Thanks, Julian, for that. Thanks for that awesome demo. So we do have some time now for questions. And if you guys have any questions you would like to ask, you can drop it in the chat panel at the bottom of your screen and we'll address them, or you can unmute yourself and ask Julian directly. So I see that there's one question from Greg. So Greg says, it looks cool, but I'm guessing the Anthos migrate tool really only works for simplistic solutions. A monolith with a bunch of scheduled tasks, etc., can surely not be so easy.
Yeah, so sorry if I can just jump in there as well. Yeah, so it seems like super easy, but obviously you did it now with a Python solution. But I mean, if I just think of most of the monoliths that we work with, yeah, it just feels too easy to just run a quick script and containerize it and deploy. It feels too good to be true.
Yeah. Hey, Greg. Long time. So I think that like if you're a large enterprise and you've got a fleet of VMs on traditional infrastructure that you just want to get containerized and potentially not as gracefully, or let's say, you need a kind of stopgap before you can actually do whatever, necessary modernization in terms of the actual development side of things. I see it as working fairly well. I've done it with Spring, and I believe you can do it with things like more traditional, application servers, WebSphere, JBoss. I believe it works fairly well, but I will agree in the sense that if you've got pretty complex architecture, and you've got lots of different things firing, you might want to put in the effort and actually think about how best to compose that service or decompose it. But that being said, I've definitely done Spring and it worked like a charm. And the entry point gets set. Systemd, depending on the base image or the base virtual machine, you actually have kind of a full systemd or init or systemd these days inside of the container. So it kind of picks up any containers or any services and just sets up multiple entry points for you, or just kind of runs it. So that does work, but I can definitely see scenarios where complicated architectures might not be the best out the gate for those things.
Or at least then it should be a short-term stopgap, while you're actively refactoring the monolith. So I think that's
I think so. I think if you're just looking to realize benefits of containerization, potentially look to use containers to enable a bit more of a hybrid architecture, get into cloud and on-prem, for example, then I think it'll definitely catalyze that. As a stopgap. I do think always the best is to align the architecture to the infrastructure architecture and the application architecture should be aligned.
Cool. Thanks, man.
Cool. I just want to point out while I'm still sharing my screen, I've got my alert coming through, so I can go and just sort things out, either scale up or look to alleviate the pressure on the service. That's actually kind of where the demo concludes. Oops.
Cool. So I see there's another question from Neil. I don't know if you want to ask it or.
Sure, I can ask it.
Cool.
I just wanted to find out, so everything we see now in Anthos, that is also available in GKE. There isn't something that Anthos has that GKE doesn't have.
So Anthos can run across GKE clusters and GKE on-prem and in AWS, but it can't manage EKS. You deploy, EC2 instances and stand up an Anthos cluster. And there are certain features that at the moment you get with GKE-based Anthos clusters that you don't get with on-prem. But that gap is kind of closing. So, for example, the mesh telemetry right now is not available to GKE on-prem, but I believe that is kind of in the roadmap. So my impression is a lot of those gaps are closing very quickly to enable kind of full feature parity between GKE on-prem, GKE and Anthos clusters.
Thank you.
Cool.
So Julian, I have a question. So you showed us the admin cluster manifest, right? And then you mentioned that it supports a few environments. What are they again?
So at the moment, when you stand up GKE on-prem, it's vSphere essentially as the host environment. So it actually uses cluster API, to talk to vSphere as a supported cluster API like integrator. And I know there's a bare metal GKE on-prem deployment model that will be supported kind of in the very near future. But currently, those are the two to stand up GKE on-prem, and at the moment, it's vSphere based. And if you want to see what the admin control plane looks like, real quick, I'll just quickly. So the staging cluster is GKE, and the prod and admin are GKE on-prem. And if we go into so this is a namespace in our admin cluster that runs the control plane components for our user cluster, which is our production cluster. So that's actually how it all gets scaffolded.
Cool. All right, guys, if you have any other questions, now is the time to ask them. So I just want to make a comment about Google Anthos and how awesome it is. Because I think as engineers, you can deliver business value from day one. You don't have to go back to business and say, hey, you have a monolith, it's going to take me maybe 3 months to break it out into microservices, and then I'll wrap it up in Docker images. And then it's going to take me like a month or two to put it into Kubernetes, integrate with Kubernetes, and then we'll be able to go Kubernetes or cloud. So I think this workflow is definitely something that is very useful for people who want to go from monolith to microservices.
Definitely. I just kind of see Greg's point, and I think there's something to be said about, doing the hard yards and doing the necessary application modernization. But I definitely see a lot of benefit in being able to catalyze that journey and allow some of that hybrid flexibility, Kubernetes on-prem or in cloud. I do think it's quite powerful.
Yeah, awesome. So guys, if there's no other questions, then we can end off the session. So thanks, Julian, for a great presentation. So just an ending note, we're always looking for speakers to come and share with us their cloud native journey. So please reach out to me if you're interested. And yeah, thank you for joining us today. The webinar recording and the slides. I hope you are sharing the slides, Julian.
Yeah, I'll
PDF
them and send them to you.
Yeah, they'll be online over the next 2 days, and we're looking forward to seeing you at the next month's CNCJ meetup. Have a great day.